All right, this video is going to be used as an example that you could use this to similarly to how you can make your model. You do not have to use this representation with marshmallows. You can use however you want to. It certainly can be more creative than what we've did. We were just making sure you know how to meet the success criteria. So our learning target is I can model baking soda and vinegar reaction to show how energy is absorbed to break the bonds of vinegar and baking soda to store energy in the products. I know that's not what your learning target says, but I didn't want to give you the answer for photosynthesis and respiration, so we changed it to this sodium and equation that you guys read about and did the actual lab on. All right, so instead of actually doing photosynthesis and respiration, we're going to show you that. So our first success criteria in this to meet this learning target is I can make a balanced equation of baking soda and vinegar. So that is right up here. Notice how there's no coefficients in here because it's actually already balanced. There's 3 carbon on this side, 3 carbon on this side, and I could go on and on. There's 5 hydrogens here, 5 hydrogens here, 1, 2, 5 oxygens, 1, 2, 3, 4, 5 oxygens, and 1 sodium, 1 sodium. So it is balanced. All right, so I met the first success criteria. When you make your video, you do not have to say that when you meet success criteria. You can just explain everything and be checking off in your head that you're meeting it. But I'm showing you how you're meeting the different success criteria. The next one is I can identify the bonds in the molecules within baking soda and the vinegar reaction. So all of these bonds here are covalent bonds. They share electrons. So all these bonds are covalent. This is the only bond that where we have an ionic bond between the sodium and the oxygen. And the sodium is giving up an electron to oxygen. So oxygen is negative and sodium is positive, and they're being bonded there. So that's our second success criteria. Now the third one is the last one, and this one's the most important one. So I can describe why baking soda and vinegar reaction results in the storage of energy based on the breaking and forming of bonds. So remember when we did the lab, baking soda and vinegar reaction actually sucked in temperature. It absorbed more energy than what it released. So when these two are combined, and a little bit of energy is used, a lot of energy is used to break these bonds. So a lot of energy over here is being absorbed to break these bonds. So, and then we're going to make bonds, we're going to form bonds over here, and there's going to be very little energy released when we form these bonds. I always spell release wrong. So therefore, the whole equation is going to be storing energy because there's more being absorbed than what's being released when the bonds are formed. So how this happens is we are going to make NaC2H3O2 plus water plus carbon dioxide. So what happens is this bond is going to be broken, and this bond is going to be broken, and this sodium is now going to form an ionic bond with this oxygen.